negative 32.2 feet per second squared times 2.46 seconds, and plus 14.3 plus 14.3 feet per second. Solve that out, and I get negative 64.9 feet per second. So there it is. So that's the velocity, and that this time we do keep the negative. Negative means it's going down. And it will be going down. So that's the answer for part B.
You just said downward.
If you got rid of this and said 64.9 downward, yeah, okay.
I found an issue with this problem.
What would that be?
Well, the horn on the general lead takes about 3 seconds. And if you watch any of the Dukes of Hazzard, they always hit the horn when they're over the jump. And it's always done playing by the time they hit the ground. They don't have to wait enough time.
Are you telling me there are inaccuracies with all the program? Disillusion me terribly. This is like telling me Santa doesn't exist. You're not telling me Santa. All right, so any questions on this problem?
Why did I get it wrong?
I don't know. Well, I'll figure that one out when I'm grading. Any other questions on this? I'm going to erase it and move on. Okay.
No way.
For that problem, could you use the normal physics equations?
If you got the right answer, and you know what you did with physics makes sense.
Yeah, I mean it looks like all the numbers just sound
I mean, yeah, I'm not going to insist you do them my way. Some of the ones on the test may be a little more dependent on doing it my way, I guess. This one's kind of lent itself to doing it in a physics-based method. And if you do it a correct method and get the correct answer, all right. I say the ones on the test may be harder to do just the straight up. Okay, so on to vectors. So for the vectors below, express them each in IJK notation. So the important thing here is to remember what I said about start with the angle between the vector itself and one of the axes, not the projection of the vector. So with this one, P, the angle between the vector itself and one of the axes, 40 degrees between the y and the 400, the vector. And so in all of these, the angles between the vector and the y-axis, there's no rule set in stone that has to be that way. You could have done an angle between the vector and one of the other axes, and then you would need to start with that. Okay, there's nothing special about doing it with the y-axis. These three just happen to do it. All right, so for P, I think I'm just going to do P and Q to get going with this, and then do B and this I'm going to skip the Q and add the S ones, just in case I run out of time. That way I cover all the techniques, because it's just sort of repetitive. If I can end up with more time, then I'll go back and do S. But anyway, so P. So I'm going to start with, as I said, the 40 degrees to the y-axis. That's the y is the j direction. So that just means that P sub j equals 400 times cosine of 40 degrees, which equals 306 J. That first one pops out really nice and easy. Okay, so now what you want to do is find the magnitude of the projection onto the XZ plane. The length is the length, not a direction, not a vector, it's just the length. Okay, this is what I was calling B. I called it B in my homework and keep calling it B. You know what I'm talking about here? You have the vectors like this. We have this vector coming up here, we have 40 degrees, like so. This is the vector, this is 400. And we project it down somewhere like that. And so this guy right here is B, this length. Okay, projection in the XZ plane. X, Z, Y. Okay? So I want to find the length of B. And so B just equals the same thing except for the signs now instead of the cosine. So I have 400 times sine of 40 degrees equals 257. And notice it doesn't have a vector this time, so it's just the length. We're just worried about the magnitude, not worried about the direction B is going at this moment. And they gave it to us as the continue on to P sub I. Anyway, so this time we're going to use this magnitude, 257. 257, and it's going in the, I think I drew this wrong, it's supposed to be going off that way. Yeah, it is. So this guy is actually going more like that. There's our projection, this is 30 degrees here. So it's going in the negative x-axis. This is where I told you to think about, if this angle was 0, all of it would be in the negative x direction. If this angle was 90, none of it would be in the negative x direction. So what cosine sine is going to give you that relation? It's going to be cosine. Cosine of 30 degrees, if it was cosine of 0, that would be all of it. Cosine of 0 would be 1. Cosine of 90 would be 0. Making sense? So I'm going to take the cosine of 30 degrees. Or you could also be negative the cosine, just go in there, or you can measure it around this way and call it 150 degrees, and just take the straight cosine. Either one would work. I went with actually 150 degree way, just so I don't have negative sign. So anyway, cosine of 150 degrees. So everybody gets this. I can either have this or negative cosine of 30 degrees. So they're identical. All right, so this equals negative 223i. In the same vein, p sub k. Stop when you have some x number. Okay. So same idea here. Take this 257. This time it's just going to be the sine of my 150. Sine of my 150, except this time it will be negative. Because see, we're going in the negative z direction, so our answer should be negative. Okay. Equally could have done 30 degrees for this instead of 150. In this case, for sine, 30 degrees, sine of 30 degrees equals sine of 150 degrees. No sign change at all. Just okay. So equals negative 129. Okay. That's the first one. So I'm going to go on to the second one. Q. So same way. You start with Q sub j, is the angle between the vector and one of the vector itself and the axis is again the y-axis, so I'm starting with j. So the magnitude of the vector was 100 times cosine, the angle between it and the y-axis was 60 degrees, so 60 degrees, and that equals 50 j. Again, I want to find the magnitude of b. Once again, it's just the 100 times the sine of 60 degrees. So that equals 86.6. All right. Now I want to find Q sub I. So in this one, it was basically going the positive x direction. So it's going to just be the this magnitude here, b, 86.6 times the cosine of 30 degrees equals 75i. Is this making sense to everybody? Yeah. I'm not losing anyone. I know I'm not drawing the picture up on the board. Yes.
Actually, you could finish that without a question.
What would be a question on this one?
Yeah, just regarding like how you get 150 degrees with K.
It's the same one as here. I'm just going around. So this is 30 degrees. This is 150. All the way around would be 180.
Okay.
So
that was for like the Z axis.
it's this. I used it first for the x, but this is measured in the xz plane. This angle is measured in the xz plane, so I can use the same angle for both x and z. Okay. Now I had to throw a negative sign in front of it because otherwise it would have given me a positive result, and I can see from this is going in the negative z direction.
Yeah.
But I can use the same angle. I could have used 30 degrees in each case for this, and then I would have needed a negative on both.
Maybe it's the first time I haven't come to.
Yeah, there's different ways to do it. Yeah, if you wanted to do, let's see, 120 for which the k value or
Yeah.
the I?
Okay.
Cosine of 120. Yes, that would work. degrees to it, and that's gonna switch it between the cosine and the sine. Yeah, it's there.
So I did the same thing with putting the negative in front for the K, but if you just go like the other way around the X circle, then you just use that angle.
Yes. There's many, many different ways to do this. It's just gonna change whether you have a negative sign, whether you can cosine and sine. You can measure the angle. That's what I'm saying. I don't have to wait like, this is the consistent way, you can always deliver it this way, you get the right answer.
But we don't have to be like, this is why I have a negative sign here for no reason, kind of thing.
As long as it makes sense. I mean, I'm gonna look at it, I'm gonna look at the angle, I'm gonna look at whether you've chosen cosine and sine and the angle you've chosen, I'm gonna try and figure out what you're doing. And if I can see like, oh, okay, that makes sense, then we're good. Okay, so continuing on with Q. So Q sub K, again, be the same magnitude here, the 86.6. So on this one, we were going once again in the negative K direction, so we need to have negative, so negative, and I'm going to the same sign, 30 degrees, equals negative 43.3 K. Okay. Yeah? Good.
Cool.
Alright, so I'm going to now erase this and I'm going to sort of skip S for the time being so that I can move on to the rest of the problems. S is just more of the same. So by the time I'll come back to it. And I am going to post my homework solutions on Moodle, so you can look at them and see what I did, whatever, if you're content. Okay, so on to B. So to B, where I'm asking you to find the dot product between P and Q. So P dot Q, okay?